Okay, Brian,
What's that?
I think we're ready to start.
Okay.
So tell a little bit about yourself and we'll go ahead and get started. And I'm going to mute myself, okay?
All right, sounds good. So my name is Brian Vander. I work at the Great Plains Veterinary Educational Center in Clay Center, and I'm sorry that I guess I could never be in two places. That would have been tough anyway, but I can't be in even one of them today because we're also lambing, and my wife gave me strict instructions not to get too far away from home. So let me share my screen, and we'll get started on this. If you have questions, this is the agenda for today is relatively simple. We're going to talk a little bit about how we think about biological risk in our livestock systems. In this case, we're going to talk about sheep and goats in particular. I'll probably say sheep or goats frequently, and to some extent they are interchangeable. If you have specific questions, please don't hesitate to ask those as we go along. I've put my phone number up in the in the slide that you can see right now. If you want to text questions as we go along, I will be looking for those, and I'll try to answer them as they come in. A few of you I have phone numbers for, so trick questions will be added with your name if I have your phone number. Anyway, we'll get the second part of this is talking about essentially one approach that you can use to implement biological risk management. And there's two key factors that I've learned, especially in the last year, is that you have to have a plan that works for you. And the second part of that is that you have to think about biological risk, not only as the risk of introducing some kind of disease into your operation, but the risk of other kinds of influences like weather on the biology that you're trying to make money on. So this last year has been a good reminder that the risk to the biology we're trying to make work is pretty high as well. So just a little bit of philosophy before we get too far into this is that a lot of the issues that we struggle with in livestock production, we're constantly kind of in the firefight mode. We see the problem and we respond to that problem. And the reason that we often have those problems is much more complex than what we can see. The iceberg analogy is pretty appropriate in this one, is that if we're working at what we can see and the response level, we're probably working at a level where we're not addressing root causes of problems. We're responding to those problems. And that may not seem very important, but I'm going to walk you through a little bit of an example here that is something to think about. And the example that I have is when we think about vaccinating our animals, like vaccinating sheep against CDT or one of the abortion-causing diseases in sheep or goats, what are we actually doing to that animal? What is a vaccine? And you can think about that lots of ways. It's a part of a virus or a whole virus or a bacteria. It contains some chemicals that really get that immune system's attention. And the other thing that you can think about for vaccination is that it's kind of a low-grade infection. We actually want that immune system to recognize our vaccine as an infection, and that has a cost. Whenever we engage the immune system, we're asking that animal to partition some of its resources in the form of protein and energy to something that doesn't create any growth. But the real thing I want you to think about is why we actually vaccinate. And I would submit to the group that we vaccinate because we need an insurance policy against things that we can't control. The problem that I see pretty routinely in our agricultural systems today, including in sheep and goats, is that we implement a lot of biological risk insurance policies and then pretend like or not pretend, but we actually act like the best way to get our money's worth out of that is to use the insurance policy. I've got this little picture of a wrecked car over here on the right-hand side of your screen. I'm guessing if that guy had the appropriate insurance that he could get a new car, but that may not be there may be some side effects to him getting the benefit of his insurance that are going to last a lot longer. And I think we should think about that in our livestock production systems as well. So I just want to illustrate the power of thought when you think about biological risk here just a little bit. This is a little shorthand version of a story, and essentially the story goes like this. A lot of us have, at one point or another, are going to experience some disease pressure in our flocks or herds, and we're going to respond to those, and we should. And we're going to respond with treatments. A lot of times when we have a problem, we're going to implement some kind of vaccine strategy to reduce the effect of that problem. And in the short term, it's very likely that we're going to take some of that disease pressure off. The long-term solution to a lot of those problems is to implement real preventative strategies. And I actually separate vaccination out and say that that's more of a response than a prevention. And I'll illustrate that with some examples as we go through this presentation. But as you think about, actually interrupting a challenge, making sure that your sheep or your goats are not exposed to a particular pathogen because you've managed that risk and removed the challenge, you don't actually need vaccination or treatment potentially if you can be certain that you've controlled that challenge. And that might be considered the long-term fix or the fundamental solution to that problem. What I see happening a lot is that in our systems, in our farms and ranches, we look at vaccination and treatment as the solution, and that gives us the feeling that we've done what we needed to do, and we really don't look at the fundamental cause of those things. We don't look below the level of the water on an iceberg, and we end up continually needing to implement the treatment and vaccination because we never really get the long-term solution in place. So we've shifted the burden from these fundamental solutions to our short-term fixes, and that basically traps us in the cycle of needing to use those more and more. If you want a really direct example of what this looks like in sheep and goats, think about parasites. In a lot of ways, use of parasitic drugs has forced us to use the anti-parasitic drugs a lot more, so dewormers and the like. So this is one strategy, and this is one that I use, but there's many approaches to managing biological risks that you can think of. I like to start with identifying goals, and we'll talk about each of these in some more detail in the following slides. I want to make sure that for my own operation and also for the people that I work with and for, that we know exactly why the operation exists. A lot of times we're going to say because we want to make money, and I'd argue that if we wanted to make money, there are probably easier ways to do it than having livestock. So there's usually something else besides just having a need to make some income. Once you've identified goals, I think there's two big things that need to be happening. You need to be monitoring to make sure that your progress toward those goals is happening. But the thing that we're going to talk about most today is how do we assess threats to those goals? And we're primarily going to focus on biological risk today. And again, I'm going to emphasize that those threats are both in the form of diseases that can cause problems in our herds and flocks, but they're also in the form of weather events and other non-infectious threats that can definitely create trouble in our systems. And then I think there's three basic approaches that need to be considered once threats have been identified. If you've got threats that are outside of your system, We want to figure out how to make sure that those stay outside the system. We have a lot of threats and risks that are inside our systems, and we want to make sure that we've done our best to contain those and limit their impact. And then sometimes there's just things we can't avoid, so we want to make sure we have a plan in place to mitigate things that we can't get around. So one of the, and I would encourage each of you to think about these things, but even further, it's extraordinarily valuable to write down some of this stuff to make sure that you have a written plan in place for how you're going to do some of these things. It doesn't have to be complex, but I find that writing things down, it commits you to it just a little bit more, and it helps you think through it. And this is you're going to find, if you have specific questions as we go along today about a specific disease or something like that, I'm going to give some examples. But this is really a strategy to try to limit biological risk, and because of that, it's relatively broad. So if you have specific questions, you can ask either Jack or Randy to interrupt, and they can ask me, or you can text them to me. Did everybody get that number written down? I can't really see very well. So first thing we're going to talk about is identifying goals and motivations. Again, you kind of have to answer the question, why do I own sheep or goats? And I think this is important because the why drives what you do and how you do it. I'll give you an example that is our family's example. My wife and I and our children, we have a small sheep flock. Both my wife and I have jobs. I work for UNL. She's a real estate salesperson. So we don't have sheep because we're trying to make a living on them. We actually probably we put a lot into these animals that we wouldn't have to. But we have these sheep because we feel strongly that it is good for our kids and for us to have animals around. It's good for us to be able to go out there and see these sheep as they're lambing, and I would like to make a little bit of money on it. It would be nice if that happened, but that's not our primary motivator. And if we don't make money, that's okay. If they lose a lot of money, we'll probably have to get rid of them, but it's okay if they don't make money. So we do this because we think it's a good way to raise our kids. It's a good piece of what they do. And because of that, we do some things that maybe don't make the most economic sense. If you saw what we did, you'd be like, that's not a good idea. But from our perspective, this is why we have those sheep. So when you think about this yourself, you have to be honest. You have to ask yourself questions beyond economic viability, because if there are things that come up as risks later on that interfere, if you control that risk, you're going to interfere with why you actually have those animals. It's going to be hard for you to manage that risk in an appropriate way, because it actually kind of violates the fundamental reason you have those animals in the first place. So maybe to add on to that, it's not just why do you own sheep and goats? Well, to make money. Economic viability is important, but why else do you have them? What else do you like about that, as opposed to selling vacuum cleaners door to door? I don't know, but just think about that a little bit. Another thing that I would always caution against is that every situation is different, and that is cliche. A lot of people will say things like that, but it really is true. And we kind of get into these best management practices mentality, that there's one best way to do things in all places. And I have seen so many examples of the situations where the best management practice in that place is the worst idea, because of the reasons that we've talked about already. Why do you have these animals? Besides making money, what other things make you prefer to have sheep as opposed to cattle, as opposed to working in town or something like that? So make sure that even if it's not the best management practice, it fits your system. Excuse me. So assessing threats is kind of a difficult thing to do. And I've tried to simplify this a little bit with a kind of this is a 2x2 table, but it's kind of a way to prioritize. So The first question you got to ask when you're thinking about biological risk is what would put you out of business if you're in the business of having sheep and goats. What types of things would just wipe you out? And then the secondary question to that is what would make it impossible for you to reach your goals? If in our case, our kids, I'm trying to think of a good example on the fly. I'll work on that one. But these are important questions to ask. You know, if you have a parasite problem that is wiping your sheep out, that would be considered a really high impact and a high likelihood. It's going on right now and it's costing you a lot of money. On the other hand, there's some kinds of things that might have a very high impact but are pretty low risk. Good example, that would be something like a foreign animal disease, right? If we got foot and mouth disease, that would probably put us all out of business. But we hope that's a relatively low impact thing, and we don't have it right now. And there's some good ways to prepare, but not a lot of them. So we want to make sure that we're focusing on the things that are high risk and have the potential to cost us a lot of money. And we want to make sure that we're not accidentally directing too much effort and attention on things that are less likely or maybe are likely but don't have a tremendous amount of impact. So again, I'm going to remind you that there are threats from biology. So these would be the things we usually think about, or at least I think a lot of people think about when we hear about biosecurity or biological risk management, which would be bacteria and viruses and parasites. And there are threats to biology, so threats to the sheep and goats, weather, predators, toxins, and stuff like that. So assess those threats. I've got some ideas, and you can use these as you will, but the idea is you really want to start working on the things that are most important to you and work your way down from there. The next part of this is to understand the threats. In the case of in the case of infectious causes, there's some real value in understanding how the infectious cause works. So if you understand how the disease spreads and what kind of factors really drive its ability to move through a population, so understanding epidemiology and ecology of that disease, things like routes of transmission, how does it spread, how infectious is it, how long does it take once that animal has been exposed to actually show disease, and maybe even more important, how long does it take from the time the animal is exposed to the time it starts shedding infectious pathogens into its environment, or it can infect other animals even if it's not sick yet. Things like environmental persistence are important. If we think about our parasite problems, those eggs are incredibly persistent in the environment. They're gonna outlast our sheep without a doubt, even through really hot summers and cold winters. And then what are the opportunities to diagnose or perform diagnostics to identify these types of things? And then for non-infectious causes, you got to be asking, what are the risk factors that are going to make a threat more painful or more important to my operation? So we'll take a snowstorm, for example. If you have a snowstorm and you're lambing in January, like my family is right now, we are very susceptible to the effects of a snowstorm if we're not prepared for that. So we've had to mitigate that by putting in a lot of other types of infrastructure, like indoor lambing and things like that. Whereas if you're lambing in May, a snowstorm in January probably will have a very, very small level. It will contribute very little risk to your operation. Once you understand these threats, you use that understanding to identify control opportunities. So find ways to remove the challenge, or identify ways that you can build resilience to those things. And that's what the next three sections are about: how you keep external things external, how you can build resilience to weather events, or in some cases, we don't have this very much in Nebraska, but in places further west, they talk about it's important to lamb when predators need less food, because it will take some of the pressure, the predator pressure, off their systems. So lots of things like that can contribute to removing some of the biological risk in your systems if you've identified those and you try to understand those threats well. One thing, this is one of the specific examples we'll kind of use as we go through the presentation today, but one thing that I've been hearing a lot about, or one particular threat that I've been hearing a lot about, is Cache Valley virus. It was a pretty significant problem last year, and it sounds from some of the discussions I've had that we're having more trouble with it again this year. So just to put this virus in the context of what I'm talking about today, if we want to control Cache Valley virus fever, or the impacts it has in our lambs, we need to understand that bug just a little bit. So it's a virus that is actually transmitted by mosquitoes. That's the major, as far as I can find for information, is the only way that virus is transmitted. And this virus, when it's introduced into a ewe, in the first trimester of gestation, will cause severe malformation. So it causes arthrogryposis. So if you see that picture of that lamb, many of you have probably seen these. It really twists up their joints and locks them, freezes them, and you get these twisted lambs that are often difficult for the ewe to give birth to. This one doesn't affect goats. Now, there's another virus that's similar that will affect goats, and it will also cause, sometimes you'll have live lambs born that have relatively minor issues with their joints, but they'll have severe central nervous system problems. So they actually get hydroencephalus, which means they kind of have water, too much fluid in their brains, and it actually has pushed some of the tissue out of their brains and made them not functional. So you'll have kind of dummy lambs or or other CNS type problems. So based on the fact that we have a vector-borne disease that has to be introduced in the first 50 days of gestation, that actually offers us some opportunities for control. If this is a significant problem in your system, the control opportunities really are centered around one of two factors. We can either try to interrupt the vector, so we can do something about the mosquitoes, or we have to do something about the breeding season. And those two interact, because if I am breeding during the vector season, I have to figure out how to interrupt the vectors. But if I choose to interrupt the vectors by breeding outside of their season, I can accomplish both of those things, and hopefully significantly or completely reduce my risk of Cache Valley virus fever and its problems in my sheep flock. There's some other general things to think about when you talk about threats. So we're going to talk about excluding external threats. So I think these would include diseases, but they can also include non-infectious risks. So these are plans that are, sounds like I'm getting a text. So yeah, the comment is that the handout you have is from last year, and the slide about Cache Valley virus says that it's 45 days and not 50, and I just said 50 days. So sheep, there's a little bit of biological variation there. When you read the papers about Cache Valley, you'll find quotes about 45 or 50. The way the research is done, probably both of those are true, and it probably depends a little bit on other factors. Part of the issue is that sometimes the way we breed sheep, it can be difficult to know exactly when they were bred. I'd have to go back and look at the research, but I think the general concept here is that you're looking at first trimester, which in sheep is going to be 50 days. If you're interested, I can send some more of that information from the literature out about Cache Valley. So going back to external threats here, if you've identified threats that you currently do not have in your system, it's worth spending a little bit of time thinking about, or perhaps working with your veterinarian or with someone else to figure out how you can work to exclude those diseases from your system. Johne's disease, for instance, can be a problem in sheep and goats. If you don't have it now, it's something that it's somewhat difficult to exclude, but you can think about developing a testing plan for new arrivals to make sure that you've done the best job you can of making sure you're not introducing that type of a pathogen into your system. You also want to think about those non-infectious risks. If you're lambing at times of the year when you're at risk of severe weather events, what's your plan if things really come off the rails, right? If you have a significant weather event, snowstorm, ice storm, and it's going to interrupt what you normally do and make it difficult for you to keep your lambs or kids alive, what's the contingency plan? And then some other things like predators and toxins, if those things are major threats for you where you are, thinking about how to keep toxic plants out of your pastures, or predator avoidance or predator control measures is something to think about, and keep those external threats external to your system. So going back to the Cache Valley virus example again, so once we talk about bioexclusion, if you haven't had this in your system and you want to make sure you keep it out, or if you have had it and you don't want to see these abortions again, you can think about doing a couple of different things. So what I've put up here is this is the temperature, the average high, the average, and the average low temperature for Clay Center, Nebraska throughout the 12 months of the year. So based on the stuff that I read about mosquitoes, we would expect them to be active at temperatures above an average of 50 degrees. So that middle line, that orange line, is the average temperatures for those months. And that's average of the day and the high and low. So we would expect that somewhere in April to somewhere in October, we're going to have mosquito activity. And if we want to make sure that Cache Valley virus is not a threat to our herd, we would breed outside of that window of April to October. We would make sure that we're breeding from November till March and not inside that window. If we want to make, if we want to still try to breed out of season, or make sure that we have lambs available to sell during advantageous markets, we might, but we still want to avoid Cache Valley, we might have to think about an alternative production system where we lamb or kid and then grow those lambs more slowly so that they're ready in an opportune market, as opposed to having them show up at the same, having them lamb in the typical season, which is going to be the spring, and then not having those animals available during a high market period. So developing it, again, it's about understanding what the threats are. It's about understanding how those threats affect your outcomes. And then it's identifying those control points that might be in the structure of how the disease works, or how your operation itself functions, and what your goals are to try to eliminate those threats, or at least make them less likely. The next step would be to contain internal threats. So if you have issues in your herd already, and the one I put up here is parasites, because if you have sheep and goats, you have parasites. They may not hurt as much, or they may hurt a lot depending on your current management and environment. But sheep and goats have parasites. If these things are, and there are other examples of internal threats, caseous lymphadenitis, or CL, would be another good example. Yonis might be an internal threat. These are diseases that if you have them and they're a threat to your goals or your survival as an operation, you want to develop plans for these types of things. One thing you can think about doing is figuring out how to make them external. In the case of parasites, that's probably not possible. Some of these diseases you could go through a cleanup. It would maybe mean a test and cull or a similar procedure. But again, it's really important to understand disease transmission and ecology to find those control points. I think I like I'll use a specific parasite example in the next slide, but one of the really elegant biocontainment examples we have in livestock is actually in cattle. number of years ago, and some of you are probably familiar with this if you have cattle as well, is that scour is a significant problem. And a number of years ago, there was some research done that showed that almost all the calves broke with scours in a relatively defined period of time. Normally, a lot of the scours would be over by 3 weeks, and when they started looking specifically at certain types of pathogens, they identified these windows when those things happened. And what the hypothesis was is that if they could, or what they thought was happening was that the calves are being born, and they would be infected by the cows with some of these pathogens. The cows are always shedding just a little bit. The first calves would get those pathogens. They would amplify them. They wouldn't really get that sick, but they would amplify those pathogens so that when the next round of calves was born, they would get a bigger dose. And those calves would maybe get a little bit sick, but they would further amplify, and those pathogens were building up in the environment. And pretty quick, the calves that were being born 3, 4, 5, 6 weeks out into the calving season were getting lethal doses. They would get big challenges. They would get very sick and sometimes die. And the intervention, and this is the elegant part, is that they basically, through moving the pregnant cows away from the pairs, found that they could restart the calving season every week or every time they moved them, and accomplish an intervention that actually prevented the scours and didn't rely on vaccines or anything like that. And that's been really, really effective for preventing scours in calves. And I've seen very similar examples of environmental contamination and buildup that kills. In one case, we looked at a goat herd that was struggling with kid mortality early on, and essentially identified the same set of circumstances. So again, understanding and developing plans to contain those challenges is really important. If we think about parasites, I think the biocontainment for this probably looks like a process by which we're going to select for animals that are genetically tolerant of the parasites. And one thing I'll say about this is that if you have sheep and goats, your sheep and goats eventually will go through genetic selection for parasite tolerance. You can either control that process to some extent through systems like FOMACHA and targeted deworming, or I've seen situations where the genetic selection happens anyway, but it just happens by parasites killing off the animals that can't handle the parasite load. Either way, you still have genetic selection happening. One of those is far more survivable than the other one. But if you use a FOMACHA system, so you're treating judiciously, you mark and record those treatments, and you retain the resilient animals, the ones that can handle parasites without you needing to intervene with parasite treatment or anti-parasite treatment, you can make a lot of progress. This little figure on the right-hand side shows the egg burden, so the fecal egg counts from a set of sheep in Australia. That one group, they didn't make any genetic or any culling decisions based on parasite treatments. And the other group, they specifically selected and kept replacements from their flock that didn't require deworming practices. And in about 10 years, they had reduced the worm burden in those animals that they had selected for parasite tolerance by 25%. So they were able to actively reduce those pretty significantly with using a targeted treatment and a careful record keeping system that allowed them to know who didn't require their help and to make sure that they kept the offspring from those animals. That's another great example of biocontainment, right? If you have a problem inside, how do you limit the risk and impact of that thing? And genetic tolerance is definitely going to be one of those opportunities. In some cases, it's impossible to stay out of trouble. There's some threats that we just cannot avoid. And in these, you have to have a mitigation plan. And this, again, isn't just diseases. This is those other non-infectious threats as well. So when we find ourselves in a situation where we have a lot of sick animals or any sick animals, what are the treatment plans? How do we choose the most efficacious thing? Can we vaccinate to avoid some of the risk? Can we do things with those animals that will limit the spread to other animals in our herds or flocks? Good example of this might be something like CL. If you have an animal that's developing a CL lesion, it's got a big lump, get that animal separated out and isolated before that thing breaks open, and put it in a place where you never plan to put anything else, because that material is the major way that CL moves from one animal to another. It's that draining material from that lymph node. Or potentially even think about culling those animals. Euthanasia is something you should always be thinking about. What are the parameters that you're going to have in place to decide when it's time to call it quits? Don't only think about that from the perspective of animal welfare, which you should think about. We want to make sure we're not causing unnecessary suffering, but think about euthanasia also from the perspective of, is there a point at which I need to implement that procedure to protect other animals in the herd or flock? No matter what you do when you're thinking about mitigation, you want to make sure that you're preserving animal health. You want to make sure that you're going to preserve welfare, and to every extent possible, salvage the economic value of those animals. The last thing, and this is a part of it all the way through, but it's something probably most important when you're in a situation where you're experiencing the outcome of uncontrolled biological risk. So monitoring to track progress, you want to make sure that you've created a plan and that you have you're watching to make sure that plan is working. You know, if you implemented a plan to control parasites and you're trying to select those that are genetically most resistant, you can oh, got a good question coming in here. What is CL? That's caseous lymphadenitis. So that's a disease. It's a bacteria that causes abscesses to form in lymph nodes. And when those lymph nodes break open, it'll infect other new animals. And normally you'll see the lumps, the swollen abscess or the abscess lymph nodes. But the major thing that happens is animals that get CL tend to waste. They'll lose weight. They'll be unthrifty. So going back to parasites, if you're trying to implement a plan to contain parasites through genetic selection for tolerance, you want to see progress, right? You want to track that over time, fewer of your animals need treatment every year, or you might do fecal egg counts or something like that. But you want to have some plan in place to make sure that your plan is working. Because if it's not, something's missing. You haven't assessed all the pieces of the puzzle and made sure that the plan is going to work in your system. There's also an opportunity to reprioritize. If you're tracking things that happen in your herd or flock well, you may discover that what you thought was the biggest problem might not be the biggest problem, and that there's actually something else that is causing more problems, and this is an opportunity to do something different. And you want to monitor to make sure you're looking out for new threats. I've got a picture of necropsy in here. I think it's one of the most undervalued procedures that we can do in our livestock systems. And I'm biased because I'm a vet, and I know these are expensive to have them done for you. But one of the problems we have if we don't do necropsies is that we can lose animals and never know why they died. And a necropsy offers you a unique opportunity to know something more about why animals died, or at a minimum, to know why it didn't die, right? We can pick out things or find the absence of signs of things that we would expect to kill them. For instance, if we have an animal die and we think our number one problem is parasites, and we get in there and find a bunch of those abscess lymph nodes, we might find out that we have a secondary or maybe even a primary risk that we're not trying to control at all. So monitoring is really important. And I would again stress that having a written plan with written records to track this progress is really important. I personally like that writing to be done, especially the tracking part, the data that we collect to be done in a computer, because it makes it a lot more easy to analyze if you need to do that in the future. So a couple of concluding thoughts here is when you're thinking about how to manage your biological risk, make sure you consider the structure of your system. Why are you doing this? What are your goals? And that includes financial, but also other goals. Why did you choose to raise sheep or goats as opposed to cattle or working in town or having some other kind of an income structure? You want to make sure that you have thought about how that structure is maybe creating some of the challenges that you see. So how does the way your system work contribute to the biological risks that you experience, or maybe you're at risk of experiencing? And use those lessons to anticipate unintended consequence going forward. We have a number of examples in sheep and goats, and I think probably the best one is parasites, how we have really been taught the lesson that the more we deworm, the more we have to deworm, which makes it very important for us to continue deworming. And I think the good Dr. Einstein put it best, is that if you are doing the same thing over and over and expecting a different result and not seeing it, you have truly defined insanity. I got a question here. Is there any health differences between hair sheep and the merino wool type? I am not aware of any. There's always genetic differences that come up because of how those animals were developed. For instance, a lot of the hair breeds were developed in either subtropical or tropical environments, and they do they're thought to have a better parasite resistance profile, maybe compared to some of the wool breeds. But I think there's good examples of people who have selected wool breeds to be just as parasite resistant as any of the hair sheep. I think it just, you might have some minor differences like that, just like you would expect to see between differences in breeds of anything. But in general, function is pretty similar amongst the different breeds of sheep. I got another question here. So the question is, I have a doe that 3 years ago tested marginal twice for CL and was in isolation so I could watch her for 6 months. No signs of abscess, so I returned her to the herd. 2 years since, she tests marginal every year. Any explanation why she has elevated levels? So there's a couple options. One is that she might actually be a low-level infected animal. So just remember that the major risk is the material that drains from those abscesses when they break. So if you want to contain it, you can have an infected animal, and she is some risk in your flock if she's infected but not showing any signs of draining abscesses. They can transmit to some degree. The problem with diagnostics for CL is that they're not great. There is some there's actually, it's not it's not a great test. It has a pretty low positive and negative predictive value, meaning that if I have a positive test result, I'm not 100% certain that that animal is actually positive. And if I have a negative test result, I'm not 100% certain that the animal is actually negative. So you've got inaccuracies in the test. When I think about a CL control program, I would be really focused in on if you're purchasing animals, never purchasing anything that has lumps or bumps. If you have wasting animals that despite some sort of a nutritional intervention, they don't get better, I would get those animals out of your flock. Those are the ones that I would isolate because they're more likely to be shedding a number of things that you don't want. And then I would be vigilant about animals that die, getting a necropsy done and seeing if you can identify those lesions on the inside of some of those animals. Another question is, how effective is CL vaccination? Does it test positive? after vaccine. I have never been, I've seen a little bit of data on CL vaccination, and I would not bank on it. It doesn't look real great. Doesn't mean it's ineffective, but it's probably, the way that bug works, it's probably not great. I am not aware, I don't know of a source for it. I could probably look that up, and it would create some issues with testing positive if you're testing for CL. Next question, is Cache Valley a problem in all of Nebraska? What is the best way to find temp data and mosquito activity for each region? I actually went on NOAA and found the data that I plotted in the graph there for you. And I'm not sure about all of Nebraska. I get a lot of reports from a lot of different places. That's not all of Nebraska, but I think if you have mosquitoes in your neighborhood, you are at risk. Next question, is there something to use to help limit parasites in pens? Actually, if you are struggling with parasitism in pens, those are parasites that the sheep are already carrying, because if there is no vegetation in the pen, transmission can occur. The way the life cycle of the major parasites, especially Haemonchus, the barber pole worm, works, is that those eggs are excreted in the manure of those sheep or goats. They are put out on pasture, and the eggs hatch and they develop into larvae, and those little larvae will actually crawl up on the blades of grass, and they have to be nipped off by the sheep as they graze in order for the cycle to complete itself and those larvae to get back in the sheep. So if you're in a dry lot, and that means a true dry lot, there's no green things anywhere, it's very unlikely that transmission will occur. If you have weeds and stuff in there that the sheep are grazing on, or the goats are grazing on, you still might have it. But there's a limit to how far those Haemonchus larvae can travel, and they're really susceptible. So if those, what they do is they crawl up and they hang in little drops of dew on the end of those plant or those grass blades. And if that dewdrop dries up before they get ingested, that larva is dead. And they can also only travel, I think it's about 8 to 10 inches. So they can't go up a kochia plant or a sunflower and get on the leaves. So there's strategies that you can implement there as well. But if you're in a dry lot or in a pen and you have parasite issues, those parasites are in the sheep. They're not transmitting. If you're deworming and they don't get better, it's because your dewormer isn't working anymore. Any other questions? Seeing none, Randy, it looks like you're up again. You're muted out, Randy. I can't. There you go.
Thanks, Brian. We appreciate it. Is there any other questions here at all? Okay. Okay. I think
Jack, you got any there?
Any questions? Doesn't look like it, Brian. Thank you.
All right. Thank you. I'll send these slides out to Randy and he'll get you a new set. That's my fault, not Randy's. I didn't get them to him on time. So. All right. Thanks, Randy. I'll send the new set of slides to Randy and he can get them out. That's my fault, not Randy's. I didn't get them to Randy on time. So.
Yeah, what we can do, Brian, is we'll put some links up so people can get online. And
okay. All right. That sounds good.
Okay. Thanks. Thank you, Brian. Appreciate it.
Yep. No problem. Have a wonderful day.
Great information as usual. We always enjoy hearing from you. And if you got questions, you can still text them too. I texted him some here earlier. He answered them. Okay. Okay, so now, I'm going to that